Within a Kubernetes context, what is the primary function of Linux namespaces in achieving container isolation? The options are: Option A, Linux namespaces restrict the CPU and memory consumption allowed for processes running inside containers. Option B, Linux namespaces enable operating system resource isolation, such as network interfaces, file systems, and process IDs, by segmenting views for containerized processes. Option C, Linux namespaces limit container processes to a specific subset of capabilities rather than giving them full root power. Option D, Linux namespaces offer a way to separate logical Kubernetes objects like pods and services inside a single cluster. This question explores how underlying Linux kernel features support the containerization model. Understanding the specific responsibilities of these kernel mechanisms is key to understanding how containers remain isolated from each other while sharing a host. In my view, the correct answer is option B. Linux namespaces are a powerful kernel feature that partitions system resources. They allow different groups of processes to have independent views of global system resources. This means one process can see a specific network stack, file system, or process ID list, while another process on the same machine sees something entirely different. This fundamental OS-level isolation is what allows multiple containers to run on a single host without interfering with one another. Let us look at why the other options are incorrect. Option A describes C groups, which are responsible for resource allocation, like CPU and memory limits. Option C refers to Linux capabilities, which are used to restrict root privileges for processes. Finally, Option D refers to Kubernetes namespaces, which are logical partitions inside a cluster, not Linux kernel primitives. A helpful tip for your exam is to clearly distinguish between Linux kernel primitives and the logical structures defined by the orchestrator.